Hey, hi guys, welcome to Cafe IO. Cafe IO में आपका स्वागत है. In today's video, we are going to continue our conversations around large language model. However, this is not a tutorial, nor is this a feature about something which you regularly find around on internet. What I have been looking when I was, reading about these articles around LLMs and generative AI is that there's not a lot of content or models being published from India. And what I realized is that most of the LLMs that are coming out, be it closed LLMs, which are protected like GPT, Claude, and Tropic, and all of that, or open LLM like the ones that Llama or Mistral and all of that are coming out, they are not from India, and there's very less or limited contribution in that space. The second challenge was that most of these models, the Indic language understanding, the language, while they do say that they are multilingual, it's very difficult, and we'll talk about in this in detail. So, in my research, what I stumbled upon is a great initiative by IIT Madras, AI for Bharat, and a startup also, curated by a lot of couple of IIT folks called Sarvam.ai. And what they have done is they have collaborated and created something really interesting. And this is actually called OpenHathi. Hathi is Hindi for elephant. So what they have done is they have created a new LLM which is built on top of Llama, and we'll talk about that in more detail, which enables Hindi or Indic language capabilities in LLMs. So you could think of this as a good large language model which is created and trained in India. Of course, it's built on top of Llama in partnership with Meta and all of that, but this is a good initiative. And what the guys at Sarvam intend to do is they want to democratize it and make it a platform and whatnot. Just a quick sneak peek into AI for Bharat if you're not aware of it. So AI for Bharat is a research lab at IIT Madras, and they work on really cool stuff. They have a lot of data sets, they have tools, models, etc. You can explore their applications like, Chitralekha is a great application if you want to do video translation. They have something called a Shunya, which is used for improving the efficiency of language work in Indian languages. They provide data sets, analytics, and all of those toolings that is required to work with language. So if you are working in this space, they have data. They also have some corpuses, and I'm not sure if you can get it from them or not, but great initiatives. And I think this is, I'm pretty sure we'll find, yeah, Professor Mikesh M. Khapra from IIT Madras. A big shout out to him. I think he's been training AI in India, doing deep learning courses, and so amazing stuff from coming out from him. So these guys at AI for Bharat and OpenHathi has collaborated, and Sarvam.ai has collaborated, which is, where's the team? And there should be some button for, yeah. So Vivek Raghavan and Pratyush Kumar both are IIT alumnus, different IITs, and both are really popular in their own circles. Right? Let's go to the model and talk about it a bit. So what this model has tried to do is solve certain specific challenges. And let's try to look at them and try and understand why this was required. So a very simple text as the price of petrol has been on constant rise since a few years. We're trying to convert that and see how these language, translate English to Hindi, right? Llama 2 7 billion is literally failing. So it says पेट्रोल का मूल्य के साथ संतुष्ट उठाना चाहे कुछ साल बाद से है, has literally no meaning. Mistral 7 billion also has, I don't even know what it's trying to talk about. कार्याल के मूल्यों के, I don't know. GBT 3.5 seems to be doing decent. पेट्रोल की कीमत कुछ सालों से निरंतर बढ़ रही है, which is a fairly decent translation. However, please remember that GPT is a closed model, right? So one of the reasons and what these guys wanted to do is fix this specific instance. So we'll talk about that in a little more detail. So what they did is they looked at the spread of English and Hindi, how the data concentrations can happen. and found out the core challenges. For example, even if GPT 3.5 supports, there's a challenge with tokenization. And so the Indic languages are not really represented efficiently, which is basically, the number of tokens required for are lesser when you talk of the same sentence in English and their corresponding translation in Hindi. Now, if you think about the downsides of this, the inferencing time would increase because the number of tokens are increasing, and also the cost would also increase when you are using some solution. So this is a problem, right? So what they have done is they have tried to take this problem, do a custom tokenizer, and then try to solve this problem efficiently, which is OpenHathi model. And here they have really achieved miraculous optimizations in the range of 3 to 4 times. So if you see, the lower the number, the better it is. So for news, YouTube transcripts, Wikipedia, preamble, which is the Constitution of India ka first part. So that all of those things, the cost of inferencing and basically tokenizing them is reducing. So this is a great thing. Another factor that they have tried to, you know, catch and capture is how a language is represented. So you represent Hindi in the form of Roman language. You could typically write HATHI, which is Hathi, instead of the actual Hindi. And that's how we usually do Hindi, right? Even on text, WhatsApp chat, and something. So it's Devanagari text versus Romanized text. Now, there the difference is less significant. However, it's the idea here is that we could look at either of the representations. That's the thing that they're doing. So what they did is I think the article is very long. I'll just try to skim through it. So what they did is they tried to expand the number of tokens it enabled in the 7 billion model parameter from 32 to 48,000 tokens. And then they did some translations using certain models like Indic translation models, and collected some data, did a little bit of training, etc. And did a little bit of translation alignment. So this is before alignment. If you see that, uh, you know, English and Hindi languages are very different. So English is not that rich of a language when it comes to, the grammar of it, but Hindi is a really rich language in terms of grammar. And I don't mean to demean any language, but purely speaking linguistically. So what they have done is they have done some optimizations here and try to align tokens more closer together from a space perspective. And then they have done bilanguage next token prediction, which is also required for doing next word prediction, etc., etc. So they have taken a little bit of illustration on that. And then they have given some samples as to what could happen. So different sort of probabilities results are coming out. So basically they have tried to find out optimal ways of predicting the next word when we talk of Hindi language. And then phase 3 was some sort of a supervised fine tuning. And then they tried the benchmarking it across different parameters, arc, pika, bullock, etc., etc. And then eventually what they have done is they have compared 4 different sets. So Hindi Devanagari to English, English to Hindi Devanagari, which is inverse, Hindi represented as Romanized text in English to English, and then the other way around, which is English to Hindi in Romanized. And so what they have found is that the users of English token embeddings of the base Llama model is effectively shared between both English and Hindi context, which is good. And eventually they go into and talking about machine translation and all of that. And finally, they're trying to conclude with the fact that they have done the benchmarkings. They have, showed where their model wins compared to GPT 3.5, etc., etc. And that's different kind of use cases like writing in English, then in Hindi, social media content moderation, etc., etc. Answering questions on passage like RAG, etc., etc. So here GPT is doing better. There's a partner that they had, which is Kisan AI, to use. So they kind of provided some data sets. So they are also doing this some sort of integration. I'm not too sure what they ended up doing with Kisan.ai, but I know that they provide Kisan AI provided their data and they are using it to benchmark it. So finally, what they have ended up is that they fine tuned the Llama to 7 billion model, and specifically for Hindi. And then the goal was to see that if it can surpass 3.5, which it in most of the cases did. Also, the representations of the language has been optimized in terms of inferencing time, in terms of token. And the idea that they present is that this model is now trained and this can be further used by other people and they can further extend this model. So that's the whole idea that they conclude this conversation with. One additional LLM which I think I should talk about is called Dhenu 1.0, which was an LLM produced by I think Kisan.ai or somebody, I'm not sure which guys did it. This is an agriculture specific model, which large language model, and works both in English and Hindi. I don't have a lot of details about it, so maybe I'll talk about that in future. So yeah, that's what I wanted to talk about today. And I was really excited when I saw this first, because it comes from India, and seeing Hindi coming as a part of a large language model, and the use cases could be really extensive. Now, if we have supporting data sets, you could extend this to other Indic languages, and it'll end up enriching much more uh, consumers in the India. You could drive more chatbots which are localized in nature, etc., etc. So the same use cases that the world is using, I think Indian audience will be also able to consume. And given that generative AI is making really easy to have those assistant bots, suggestive, or AI driven productivity kind of stuff, it would help a lot if it comes in our day-to-day life, specifically in a language which people really understand well. All right, so with that, Akar, this is Akar signing off. Bye bye.